Dan Tokar here at the Willow Forge in Shepherdstown, West Virginia. Sweating a bit in the heat, but today's Blacksmith dictionary is actually 4 different things, all kind of rolled up into one. I'm going to show you cannon mold used to cast silver, the rolling mill to reduce that silver, draw plates to draw it into round pins, and these are, I guess the fourth part is the continuation of my friend Steve's silver project, where I have made a couple of pins. This is the 1/8 inch diameter pins and the 3/16 inch diameter pins that he'll use in his knife making. They go along with that silver guard material that we made in a prior video. A little casting. This is sort of a continuation of Steve's silver, where the little bits of silver that were cut off the end for the shrink cavity, the pipe on the ingot that got cast and forged out for his knife guard material is saved, and you melt it down again to make the pins that he might use on those knives. So there's about 4.5 ounces of silver that will go into this roller crucible, and I'm going to cast it in what's called a cannon mold. They're called cannon molds for 2 reasons. Not because anybody ever cast cannons in them, but because they are round molds, round ingot molds. You need a heavy wall because the mold has to be massive enough to chill out the metal so you don't accidentally solder or braze the molten metal to the inside of the mold. So you need a fairly heavy wall, and it has to be straight and absolutely smooth on the inside. So this is the one we're going to use today. This is a small size one that'll cast a 1/2 inch diameter round. And just to give you an idea, there's the plug at the bottom. I don't know if I can actually give you a view down the... Yeah, you can see how that's kind of shiny. I'm going to put my little pocket flashlight in the end of that. And you'll get to see that that is a smooth, polished surface. There is no seam. They sell what is called dom tubing, drawn over mandrel, which is smooth and straight and has no seam in it. And that's what this is. This is a piece of dom tubing that has, well, I will admit I kind of polished it, lapped it a little bit to get it smoother. And it just has a slightly tapered plug that goes in the bottom. And you have to put a little bit of mold dressing. Some people will use acetylene soot. I prefer sort of seasoning it with a little bit of oil. And I'm fond of lard oil. It's basically the stuff that machinists use as a lubricant when doing tap and die work. So I'll just take a drop or 2 of lard oil on this rag and move it around so that it's just slightly saturated. Slightly saturated? We'll just say so that there is some lard oil on there. Not enough that it runs off, and you just push it through. You can even do that a couple of times. And it adds a small barrier layer so that, again, you don't accidentally braze or silver solder your ingot into your mold. It also makes a reducing atmosphere. I've put the oil on there. I will also take a clean rag and take the excess oil out, because it's just a very thin film of oil that goes on here. If you have too much oil, it can actually combust because the second reason these are called cannon molds is they will occasionally explode the contents and shoot them across the room. So you never have one of these things when you're pouring that's pointed toward you or toward anything you're particularly fond of, because occasionally they will burp. They'll either have a little tiny bit of moisture in them, or the oil will volatilize if there's too much in there, and it'll shoot the hot contents of the mold like a cannon. So again, I'm making sure that it's almost nothing left in there. It is just a very thin, shiny film of that lard oil. I'm going to put this away. But just to show you that this does scale up, this is a piece of larger dome tubing, and this rod is a brass rod that I cast from old shell cartridge brass, and it was made in this mold. This mold will do a 1-inch rod like this. So it's possible to make nice straight turning stock. I mean, this is 1-inch and 5/8 inch bars that I cast in cannon molds, and you can see you get a fairly good surface. You still have to machine to a clean surface, but those are solid rods. You have a shrink cavity or pipe on the top end, again, even with these, so you'll have to cut off 3 or 4 inches even on a good casting. But again, this isn't just any piece of pipe. This is a piece of dome tubing that's very heavy walled, perfectly straight, and has no seam and almost a polished surface inside. The other thing which helps explain what happens with cannon molds is that the hot metal shrinks as it cools from going solid, and it'll shrink away evenly from all sides, so the finished rod just pops right out, drops right out of the mold. It's not a full-size rod, so you don't have to hammer on it to get it out, or at least you shouldn't have to. So what I'm going to do is I'm going to take my little crucible, take my silver. It's about 4.5 ounces of sterling silver. Put this in the fire, and then I'm going to go get my safety gear to get ready for casting it, because it won't take long to cast this, and I want to have my safety gear ready, because even though this is a small quantity, anytime you deal with high temperature molten metals, there is the potential for accidents involving steam explosions or ignited materials like that mold dressing oil. If there was too much of this lard oil in there, it could ignite underneath the molten metal and shoot it back out. So I'm going to put this away. This is my safety gear. I have a Nomex hood and a nice leather welding jacket, which is really good for this kind of work. And also I'm going to have a pan to catch any of the silver which misses the mold, because silver is valuable enough that you don't want to have any little bit of it go missing. I'm taking my vice grip and attaching the pan. It's just a sheet steel, an old baking pan. I'm going to take this, and I'm going to make sure that the end is solidly in there. It's got a very slight taper which helps hold it. And then I'm going to use the C-clamp to hold it in the pan, and again, I'm going to have it pointing away from me when I cast it. I don't want to have this thing angled. You can see that it's got an angle. I don't want it angled toward me or toward anything that I would worry about. So I will put a little stand there. So there, you see it's pointing that way. Okay. Got my tongs. Well, this is heating up. I'm going to put on my Nomex hoodie. Nomex won't melt or burn, but it will char. It gives you a certain amount of protection against stuff, and without anything on your head, if you did have a little bit of molten material bounce off of something, you don't want to get burned on your face or your head. And with the leathers on from the welding jacket, my arms are protected, and I will have a nice pair of welding gloves that I use. So I'm covered pretty much anywhere this little bit of metal might splash me. It is no laughing matter, because even though silver melts at a relatively low casting temperature, it's still going to be close to 2,000 degrees. So I don't think you want to have anything like that touch your skin, even in little tiny droplets. Now, if I'd have been thinking, I would have had the fire much hotter before we started the video. But, well, you know, it's a small quantity, and even starting off relatively cold, this should not take long. To go back to the start of all of this, my friend Steve inherited some silver place settings, spoons, knives, forks, from a relative, and because he is a knife maker, he thought that having some sterling silver guard and pin material would be more useful to him, because you know, who actually uses silver forks and spoons anymore? So I'm converting it for him in exchange for a percentage of the silver. And I do a little bit of silver work on the side. I'd say it is part of the business, but not a very big part of the business. More for my own amusement. Silver is kind of fun to play with. I've made a lot of Christmas presents. As I try and tell some of the young men that want to learn about metalsmithing, blacksmithing, they all want to start off by making swords and knives, and I tell them you're better off learning how to make pretty things for women. This tends to work out in the long run much better than making knives. All right, the bottom of the crucible is red hot, and the silver has begun to melt. It does not take long for silver to melt. I always judge the right time for casting silver when the puddle in the bottom of the crucible is shiny in the center, and you sort of have a little ring of the flux and stuff that you have in there with it, and it's sort of dancing around. If it's just sort of sitting there, it might not be hot enough to pour, because just because it's melted doesn't mean it's hot enough to cast. A good casting temperature for silver is maybe 200 or 300 degrees above its melting point. There, it's all melted in there. I'm going to add just a little bit of borax. A safe way to do that is to use a dry ladle and just put it right in the crucible like that. You can also use this as a way of adding more metal if you have an inconvenient shape that doesn't fit nicely in the crucible. Okay, that's dancing around nicely in there. Okay, I am going to get my gloves on, because we're about ready to cast this, and I will cover my face up with my Nomex hoodie so that I don't get burned if anything bad happens. It's better to be prepared than to be sorry about it afterwards. I've had enough second-degree burns and a few third-degree burns to know that it's no fun. I want to grab the crucible about in the middle, and I have a little tiny pouring spout. Yep. A few drops of silver came out. I'm going to put a little bit of flux in the crucible before I put it back in the fire. Because crucibles can have thermal shock. You don't want to just put a hot crucible down. Alright, I pretty much filled up the mold. I will show you before I take this apart that it is filled up pretty much to the top of this little mold. So I'm going to unclamp it. And of course the mold is very hot now because that was red hot silver. I've got to put this in the vise to get the plug out of the bottom. See, plug came out, and you can see the silver in the bottom of the mold there. I'm going to cool this whole thing off now. The whole thing is now cool, and that rod of silver should just let me take my safety gear off. This is kind of inconvenient. Okay, still a little hot. So, we've got our little rod of silver. I got to get it out of there now. Darryl was telling you just a little while ago that you can just push these things out. Well, let me get a rod the right size to push with. Yeah. Can you see it coming out of the mold? You see it coming out of the mold? Sometimes they're a little tighter than others. This one's pretty tight. Almost all the way. Boing. So, what did I get that way? I ended up with a nice cast rod of sterling silver. And this will get hammered on and drawn down to make pin stock for Steve's knife blades. This is a rolling mill. Specifically, it's a jeweler's square wire rolling mill. It has a roller with grooves that will make a square rod. The largest size on this particular set of rollers is 5/16. And I brought it out because I'm working on the Steve Silver project. This is the bar that came from the cannon mold casting, which if you're a good watcher, a good viewer, you saw before. So that's how far I forged it. I just hand hammered it into a square and took it down to the size that would fit the first groove on this machine, which is approximately 5/16 of an inch. I had to go through about 6 annealing cycles, and that's not terribly interesting to watch me forge a bar into square and anneal. It's not a whole lot different from what I went through when I made the plate, the bar of silver. It's just anneal, hammer, anneal, hammer. But now that it's down to 5/16, I'm ready to use the rolling mill. So the little handle up here adjusts these 2 gears that drive the bearing blocks up and down on this particular mill. So what you do is you loosen this up and you put the rod in and you get an idea of how loose it is. And for the first couple of passes, you just want to kind of gently turn it into a square. So I'll bring it down until I can just feel, you see how the handle moved? Till I can just feel it starting to grab. And I'll back it off and I'll do a pass. Because the first pass or 2 is more or less just to make it more regular. Because even though I'm pretty good at hammering, I did not make a perfect dimensional square. At least not as good as a rolling mill. So you're just hitting the high spots at first. So I'm going to take this down 1/4 of a turn. And what I'm also doing is that I'm passing it through the rollers one way and then turning the rod 90 degrees and passing it back through. And that way you can maintain a perfect square without kind of creating a diamond. Because as you adjust this down, you could have one dimension be bigger than the other and end up with a diamond shape. So you always do 2 passes with a 90-degree rotation in order to maintain the square. Okay, turn it, feed it back through the other way. And since I'm just hitting the high points of the rod at this point, it's not too hard. And when I get full contact, it'll start taking a lot more effort because a 5/16 bar of sterling silver is a pretty hefty piece to be rolling cold. You begin to see how it's beginning to get a kind of a nice, smooth, shiny surface instead of my hand-hammered surface. And the edges are beginning to get squared up nicely. At some point, it'll also get stiff enough that I will have to anneal it to be able to do it at all. Yeah, it's beginning to get pretty full contact. So this first couple of passes more just to make it a true square. Oh, there it goes. Yes, it's making good progress now. And you'll notice how much longer it's getting. Rolling mills are great at making small stock longer quickly. It's very efficient, a lot faster than hammering. And this might be the last pass I can do because it is starting to get pretty stiff. And big bars, you're better off annealing them instead of fighting them. There. All right. So you see how long this is now, but it's a nice square. So, continuing along with the next groove, doing the same thing. All right, and that bottoms out that groove. So when I do this, it'll be time to anneal again. Starts to be quite a job as these things work hard. That's another sign when things are getting pretty tight as I keep dropping them on the floor. Just making sure everything's gone through in every direction. Yeah, and that's tight. And I've got 2 bars because I'm going to make 2 sizes of stock. So I've cut it down a little shorter and a little longer because this will be the heavier stock. So it starts out fairly long. This one will get drawn down further, so it will end up being the same length but a smaller diameter when I'm done. Okay, annealing the rods again. I tend to change over to propane torches when you have these smaller rods because the flame is a little softer and bushier and you're less likely to accidentally melt a section of a smaller rod than you are with an acetylene torch. And acetylene can be bad for silver sometimes in small sections because you can have a chemical reaction with the silver. But what I'm going to do is take the longer square rod and forge it into an octagon in preparation for it being drawn into a pin, into a round pin. And this smaller one I'm going to roll smaller, and it'll end up being about as long at about maybe 2/3 the size, and then it will get turned into an octagon, and they'll both get annealed. So there's the shorter of those 2 rods. It's going to get drawn down. I've got to open this up a little bit. There it goes. Right. More. And a little more. And again, I'm turning it 90 degrees every time it goes through the rollers. And you see, like I said, the smaller one is now almost as long. If I do one more pass, I'll have a thick one and a thin one that are the same length. That. Yeah, I think, again, it's always a good idea to drop things. Now you see the smaller one is actually longer, and I think that's all that I'll need the rolling mill for, because this is now small enough that it will turn into, I think what we're going to end up with is 3/16 and 1/8 inch round pins out of this, and more than a foot of each. I've got this stock that I've just rolled, and the first thing I'm going to do is just straighten it out. Tap it. Okay, gently straightened out. And this will need to be annealed before I forge it into an octagon, but it's actually a little bit longer than the heavy rod. So if you wondered why I started out with where I cut it, it was actually a little bit shorter. All I'm doing is turning the big rod now into an octagon. Will make drawing it into a round much easier if I have already broken the corners. And I'm just gently tapping it on the corners. Around, do the rest of the rod. Changing the shape like this is actually more stressful on the metal than just taking it down as a square, because you're working the corners much more than you are working the body. So even though there isn't a big dimensional shape, the geometric change means that there's a lot more stress on the corners. So you really should anneal after you turn this rod into an octagon, because you could have splitting and other bad things happen. I'm just straightening it out. All right. So these two will get annealed again. At some point, you need a long enough length for your rods. I hope you could see all of that because it was just a very light red all along the length of the rod. And this one, and we're now going to use the draw plates to make this into a round. Forging the smaller rod into an octagon from a square, just breaking the corner. All right, and this will get annealed all by itself. Okay. We're at the point where we need to talk about draw plates. Draw plates come in all sorts of sizes and even some shapes like square and octagon and even triangular. These are tungsten carbide insert plates that came from our friends in far off countries. And you have to lubricate these plates by putting a little bit of wax. Beeswax will work, other things will work, but yeah, you need to put a little bit of wax on the work before you draw it. So you have like this. I will take some wax. Whoops. Yes, there I am. Get the wax over everything except the work. Yep. Oh, there's a little burr right there. But anyway, and then I'll coat the other one as long as I've got wax all over my fingers. This one is small enough that it won't fit in any of the holes on this one. And then you have draw tongs that have the little heel so that you can grab things easier. And you find the first hole that it won't go through. Like right there, it's got just a few corners. Pull it through and you keep going. Each time it gets a little bit rounder and a little bit smaller. And sometimes you've got to point the rod to get it started. There, I gotta get a good enough grip. All that wax makes it slip. You can see why I made an octagon out of the rod, because it's the corners that are getting worked down in this first couple of passes. All right. So I'm going to have to forge or file just a little bit of a taper on the end of this. Again, the camera is never in the right place. So I just make a little bit of a starting taper so that it'll go through enough so you can grab it. All right. And then back again. My little starting taper. Sometimes these heavier rods do take a bit of force. You can set up a draw bench that uses a winch to pull these heavier things through. I'm just getting some slippage. Too much wax on my tongs. All right. I'm kind of stuck there. Just a second. There. Now I'm going to use a different draw plate. A smaller range draw plate for this rod. And again, I hunt to find which one will be the starting hole. All right, have to point this one. Again, I'm just putting enough taper on it so that it can start. There's the next one. Oh my, this is tough. I might just go ahead and use my friend Mr. Vice Grip. There! Because it is sometimes hard to get these things to feed. Alright, and on such a big rod, the first couple of draws are very hard. So, believe it or not, I am going to anneal that again and put a little more of a point on each end. More wax. I'll even put some on this rod. Okay, so we've got the small don't have as much of a taper on there as I thought. Yep. Need to put just a tiny bit more tape on it. All right. Tiny bit more taper. Much better. All right. Almost. And you see, we're getting much closer to a round now. All right. It's hard on these larger sizes. Sometimes I have to resort to parallel jaw pliers to get a good enough grip. There, that helped. Not every tool works in every situation. All right. Just a little bit more filing. Like I said, it's sometimes hard on these bigger sizes to get enough of a start to get a good grip. So also, this has gotten pretty hard. It probably, oh, that's interesting. It does need to be annealed. Hey, the final draw. This has been annealed, and then I very lightly went over it with some sandpaper and cleaned it off. And there. So that is now 1/8 inch. It's now 21-inch long piece of 1/8 inch silver. I'll straighten it out a little bit gently to make a straight pin. But that's the pin stock. All right, this is the heavier stock again. Oh, yeah, coming up toward round. That's probably as far as I can get it without annealing it again. Okay, there we go. Oh. Oof. Quite something. Complete my friend Steve's silver project, where I cast these in a cannon mold, use a rolling mill to reduce them, and then a set of draw plates to draw them to the final diameter. So you could say today's Blacksmith's dictionary is cannon molds, rolling mills, and draw plates to make silver pins.